Alright, so I realize it's Saturday. I wanted to go ahead and do a stream though because it's pretty easy for me to record these with the setup I have through OBS, so I wanted to just do that because I have something to say and I wanted it to end up in the same archive thing on Twitch and then eventually YouTube. So on Friday, I got stuck trying to create this Ngram Explorer example for Mary Margaret's situation, for her question. And I discovered that, well, it was one of those things where I kept having the feeling that I was going about the problem the wrong way, and I kept thinking about it. And I couldn't get my head around what I needed to do differently. I was thinking about it late last night, and then I woke up this morning and I knew what to do. It was one of those situations where I woke up this morning and I was like, oh, of course. So I refactored a lot of the code, but it is pretty similar, and there's one major difference. I don't know if it's worthwhile to explain it, but I guess I can try. In this case, I've got it running on that very large corpus that I did, and it worked. It actually completed. Yesterday, I also got it to complete doing I got it to complete, like in the earlier version of the way I was doing it, I got it to finish processing all of Jane Austen, those 3 Jane Austen novels, and it took like an hour and a half for 3 novels, and so still very, very long, way too long. But I've got this going now where it does the entire corpus, 120 or so books, in about 20 minutes. So that's a lot better. That's a huge improvement. I don't know if it's worthwhile to explain it, but basically I build this allgram dict object, and then instead of like searching each book for each engram, because that's what's taking the most time. I'm recording the engrams as I go, and then just basically collating all of their counts into that dictionary, since I already basically have it. So I don't have to look for it again. I already have it. So that was the big shift I made. I don't know if it's worth explaining it in more detail. I'm honestly kind of, I don't know. It gets kind of wonky, and I've tried to comment it out pretty carefully here. But this little function here is the one that collates it all back together. And this function, it takes about 20 minutes. I had to upgrade to a high RAM workspace to do that. But it ended up, it took 20 minutes. But then this took about a minute to collate it all. And then it works. Now, let's talk about what it actually does. So this goes through every book in the corpus. It finds all of the possible engrams, starting with bigrams, going up to 7 grams. And then it basically creates a search index of these. Like this, I think this is kind of how search engines work. So this is not, you can't do fuzzy searching, but you can do specific phrase searching, and it'll return exact matches. And this little engram search function just kind of tests that index to sort of confirm that this is telling me what I think is there. So it was the best. That's a phrase that obviously shows up in Dickens' Tale of Two Cities, but it also apparently shows up in other places. And the way that this engram search function works is it prints out the top scoring documents in the corpus for that engram, if any. If there's none, if you just give it some nonsense, it'll just say none found. Right? So this is a basic little search engine thing that this code puts together. It's pretty neat. So let's see, or let's find another. In testing, I found that the phrase "I don't know" is one of the most common. Actually, you know what? This is not going to work because we've been removing non-alphanumeric characters. I wonder if this ended up being tokenized like that. Yeah, there it goes. That's kind of awkward, but you can still see how "I don't know" is a very common phrase to occur. So. Yeah, it works, right? I mean, that's the main thing. Now, in Mary Margaret's situation, we were interested in finding not just a way to look for engrams that we already know, or that we type in and then see where they show up, but can the code tell us where there are interesting overlaps and co-occurrences of engrams that we haven't even thought to look for? So that's what this part does. It looks like a lot of code, but a lot of this is really just formatting the output in a way that's reasonable. And this is also a pretty flexible function, so it does several things. It asks for a phrase length to look for, and so it's going to return either a set of information about 2 grams, 3 grams, 4 grams, 5 grams, however many grams you want. And it's got this other way that you can change the distribution. So there's two different ways to think about the popularity of an n-gram. There's just the raw count of how many times it shows up in the corpus, and then there's also the distribution of how many documents it appears in. And so I found that that's, like, sometimes you want to know if something appears in all documents, but just given, you know, the 120 or so that I'm looking at here, there are very few that show up in all documents. Once you get past 4 grams, I couldn't find any 4 grams that appeared in every document. But it's an interesting thing to control for and try different options with in terms of that as a parameter. So that's what you're changing there. Limit is just going to say how many results to return. Like, some of these will return millions of results, I think. So you don't want that. So it's going to create essentially a spreadsheet with millions of rows, which is probably bigger than it needs to be. So you can set a limit and just say, I want the top 100 or 100 or 1500 or whatever. And then action is, you can either have it preview the output right here in the cell, or you can have it save the output to a file. And so if you give it a file name, it'll save it to that file name. So let me show you what this does. So let's say I want to find all 5 grams that appear in 80% of the documents. And I don't know how many there are going to be, so I'm going to preview that and see what I get. Sometimes this does take a bit. Okay, great. So it did not find any, it looks like. It actually returned an empty data frame, which is interesting. I thought it would just say nothing, but okay, let's see if there's any 5 grams that appear in at least 50% of the documents. There are. Okay, great. So this is kind of hard to read, but this is a spreadsheet, essentially. It's a CSV output. And we can see that in the middle of is a 5 gram that appears 239 times in the corpus. And then we can see, if we would like to see in more detail, where it shows up in. It does seem like it shows up a lot in Chesterton's books, which is interesting, I guess. I don't know. Maybe that's not interesting. But all told, there are 4 5 grams that appear in everything. So let's save this to a file. 50. Let's just call that 5 grams dist 50.csv, and save this into a file that I can look at. So it's going to show up here. I had to refresh it so it'll show up, and then I can double click it and just preview it in the notebook, or I can download this and play with it in Excel or something else. So you can see it's quite a wide spreadsheet, but you can see where the concentrations are. It looks like it occurred, where was it? I wonder, it might be useful to try to sort this way, like sort it by the most occurrences in a particular, like, so that the horizontal one is also sortable. I don't know if you can do that with, I'm not sure how to do that, but you can, looking around, you can see that this in the middle of does have a few places where it shows up. Yeah, it shows up a lot more in Cervantes, I guess. Now these are raw counts, not frequencies, so it's not super revealing that it shows up that more. Like Anna Karenina, Don Quixote are very, very long books, and so that's why perhaps they have 21 references to that. So yeah, that's interesting. Okay, so that's the kind of thing you can find with this. Now this is a really big corpus, and so the number of n-grams that are going to co-occur are going to be kind of small. So let me I'm going to make a copy of this just to kind of show you how this would work from the beginning, and change it a little bit around and actually run it here so you can see how long it takes to run these things. And then, of course, I'm making this open. I mean, anybody can use this notebook if you want. I shared it in Discord, or I will share it in Discord. This one. Let me share it now. Here's the notebook where I figured out some stuff. Okay, yeah, I know I'm sharing a lot of these notebooks here in Discord, but okay, so here's a copy, and so let me kind of start this from scratch. Of course, importing some modules that are going to be useful. I should not need the high RAM runtime for this because I'm going to use a smaller set. Let me connect to my drive so I can load some files. And it's just mounting that drive. just a few functions. Now this is going to be, instead of looking for all of the files, like I have this all, I have a folder called Chesterton, and then within that I have 21 or 2 files that are actually GK Chesterton files, and then I have like 80 or 90 others. But all the ones that are by Chesterton are named Chesterton dash something, so I'm going to, if I do this, this should just give me files that have Chesterton in the name to begin with. So this will be a smaller set than what I just did in the other notebook, but it should finish, a lot faster, I hope. Yeah, it took 20 minutes to do the one before, but when I was doing it on the Jane Austen corpus of just those three books, this script process here took about a minute. And so I expect this might take 2 or 3 minutes. We'll see. You can actually watch how long it's taking if you hover over this. So it started at 3:23, and then when you're done, it'll tell you how many seconds it took to execute. So we'll see how that goes. But ultimately, this is meant to be, you can use you're welcome to use this, Mary Margaret or whoever. You're welcome to use this code in your own. You might need to adapt it a little bit, but it'll give you a lot of data, and then you can start exploring it and see if there are patterns that you're interested in pursuing further. And of course, I can help you figure that out, how to pursue those further if you'd like, if it helps you develop a hypothesis. So, okay, so that's done. That took, how long? Oh yeah, less than a minute, so 51 seconds, not bad. Okay, so then this collating step here should take not very long. And this was the step, again, that took initially 4 hours, and then, because I was doing it a different way, and then I did another different way, and I got it down to 1 hour 20. But this is, yeah, it took 3 or 4 seconds this time. I don't know if you can tell, but this is like a dictionary of dictionary of dictionary kind of structure. So it's like a 3-dimensional dictionary, I guess is what you call that. But it works fine, And then I can preview that to just make sure that it makes sense, and it does. And then let's make it searchable, define that, and see if he uses this phrase. I don't know. It looks like it. Yep. So I don't know. That's would be in the text typographically as I don't know, and it shows up 13 times in The Wisdom of Father Brown, but it also shows up in many of the other works. Okay, so let's do the big one. This is going to just define this function that does all this stuff, and now let's see what we can find. Let's try to find some phrases here. Let's look for any 5 grams, let's do 4 grams, that show up in all of them. Let's see if there's any that show up in everything 100%. Oh yeah, there are. Good. Okay, so the end of for the first time and at the end of. There are 3 5 grams that show up. What if we change it to 90%? Are there any, sorry, I said 5 grams, I meant 4 grams. Are there any 4 grams that show up in 90% of them? Yeah, it looks like those all show up in 90% of these books. That's a pretty interesting set right there. If I want to save this, I can go ahead and do that. 4 grams, distribution 90. And then that should save that as a CSV. Now the CSV, this is in that temporary file storage area for the Colab notebook, so I'd have to download this if I wanted to really work with it, but it's also just, I just kind of want to look at it right now, so I'm just opening it up here. So yeah, there you go. Those are the books it shows up in. This little preview thing is pretty nice for CSV also. This is just the thing built into the Colab notebook. So yeah, that's it. This is a pretty comprehensive Ngram exploration tool, I think, or pretty. I don't know. There's probably better implementations or people that have come up with ways to do this already, but I'm pretty happy with what this does so far. I can think of a few other things you might be interested in doing, like looking for like how evenly distributed an Ngram is, or a way to sort by which things include it more than others. If you think of like on Voyant Tools, there's something like this on Voyant Tools. And I can show you that because I noted a pretty important difference with what Voyant Tools does. Because I was thinking, like, I'm trying to do this and it wasn't working, it was taking forever. I was like, surely, like, this is a solved problem. Like, surely this is something someone's done before. And so I was thinking, like, oh yeah, like in Voyant Tools, so this is the Jane Austen corpus, you can look at the list of phrases, and this looks like the same kind of thing I'm doing here. It kind of is. and you can see this little sparkline thing shows you the occurrence in different documents. It would be pretty cool to implement something like that. The thing that's unusual about this or different about this is that I had to look into the documentation for this, but it actually does not search across like as far as the phrases that it finds here. It looks for phrases that occur at least twice in a single document, and then it searches for those. So if you had a phrase that appeared once in every document, that wouldn't be visible here. Also, I noticed that it said that it excluded phrases that had stop words in them, or at least I think that's what it said. But clearly there are phrases here with stop words in them, so maybe that's just incorrect, or maybe I misunderstood. So this is similar. I will say that it does something kind of similar, but the actual code that does this processing is not, like I couldn't find it. It probably is somewhere out there, but I couldn't find it on the GitHub repository for Voyant. But in any case, I've got something that does something similar, but it's a bit more comprehensive, and also I understand what it's doing because I wrote it, so that's something that I can explain better if someone wants to work with it. So, okay, so that's all. I just wanted to show you that. It came together pretty well once I kind of figured out what to do with it. There's a lot of code here, but it is what it is. It works, I think. So if you'd like to try it, let me know how it goes. And if you would like me to, and the you here, I mean primarily, of course, is my students. I don't know who else might be watching this, but students, if you are at a similar point that Mary Margaret was at, like you're not sure where to go next, please talk to me so I can help you figure that out. I'm happy to write you some code that'll help you move along. So yeah, that's all I have for now. Thanks for watching. I'll be doing, I don't know what I'm going to do next week, but I'll probably be doing more streaming, hopefully. Hopefully I'll have a chance to work on Allison's problem next, because that one's an interesting one. So, okay, great. Yeah, that's it. I'm going to stop.